Hello, my name is Ryan Massey, and I'm an AVS Cloud Solutions Architect at VMware by Broadcom. Today, we're going to talk about deploying and configuring a firewall network virtual appliance inside of the AVS SDDC. Why use an NVA or network virtual appliance firewall within AVS? Well, there are a few different reasons. Customers often want to use their existing firewall solution to retain the proficiency of their firewall administrators and security teams. Most likely, you already have teams in place that are administering firewalls such as Palo Alto or Checkpoint or whatever the firewall solution is that your company owns. Another reason is routing traffic through an Azure-based firewall can introduce design complexities. This could be the subject of an entire video, but this video will concentrate on deploying an NVA within AVS. NVAs are easy to install and configure in AVS. You deploy an OVA just as you would in your on-premises VMware data center. So just like you're deploying any other virtual appliances, you would do that within AVS. It's going to be very similar to your on-premises data center. Another reason, familiar VMware platform for administering the firewall VM. This is going to be just like it is on premises, so your VMware administrators will be familiar with the processes needed to install this VM. Another reason is you want to apply advanced filtering that the firewall provider has built in, such as layer 7 app ID filtering, or SSL inspection and decryption. These are some of the things maybe that the native NSXT does not offer or does not have. NSXT within AVS does have a lot of capabilities, such as distributed firewalling, IPS, IDS. There might be some other firewall features that you want to use within your firewall solution. In this video, we will go through how to configure NSX and configure a firewall network virtual appliance from Palo Alto. Most other firewall vendors' network virtual appliances will be similar in setup. Keep in mind that this is one example, and there are other ways to architect a solution using an NVA in AVS. This should give you a good idea of how to get an NVA working within AVS. The first thing we'll do is look at an example topology that will be used in this demonstration. AVS is deployed with the default installation of NSX and is already configured for use. In the default configuration, a tier 0, noted here, and a tier 1 gateway are set up by default. The tier 0 router is owned by Microsoft, and BGP routing has already been set up. Configuration of the tier 0 router is controlled by Microsoft, and we will not need to configure anything for it. We will do all of our configurations on the default tier 1 router as seen in the diagram. This default tier 1 that is created during the AVS deployment process is named after your tenant ID with T1 after it to denote the tier 1 router. This default tier 1 router is connected to the tier 0 router by default and propagates routes automatically to the tier 0. We'll also be setting up an isolated tier 1 router. The Palo Alto NVA sits between this isolated tier 1 router and the default tier 1 router in a sort of firewall sandwich configuration. In this scenario, a management segment is set up to house management IPs of any NVAs that are deployed within AVS. This management segment also contains the outside interface of the firewall. This configuration can be customized to the customer's needs. For example, you could separate the segment for management IPs of this Palo Alto and create a separate segment for the outside firewall interface if you choose. The outside interface just needs to be on a segment that is connected to a tier 1 router that is also connected to the tier 0. The default tier 1 router is automatically connected to this tier 0 router. However, you could create another tier 1 and connect it to the tier 0 if you choose for a different configuration. As you can see below, an isolated tier 1 is created and configured with no connection to the tier 0 gateway. This isolated tier 1 gateway will route directly to the firewall NVA. To allow the firewall NVA to have connectivity on the isolated tier 1, a transit segment can be created. This is labeled a transit segment because the inside interface of the NVA is sitting on this segment. This is where the tier 1 gateway will route to. And you can see here, we have created a transit segment. This is a /24. You can make these transit segments smaller if you're just going to use them as a transit segment, for example, or you can just create a workload segment and use it for workloads as well, and just make sure that you have the inside interface of the Palo Alto on a segment. For example, in this topology, we have designated an RFC 19, 1918 we have designated an RFC 1918 address space of 192.168.21.0/24 for this transit segment. Other workloads can sit on this segment as well, or you can even use a smaller address space if you only intend to have this segment used for routing traffic to the NVA. The Palo Alto will now have management IP, an outside interface on the management segment, and an inside interface on the transit segment. We will discuss the Palo Alto configuration in a later demo. To make this work, static routes will need to be created on the default Tier 1 gateway to the isolated Tier 1 segments. I have included a couple of workload segments in this drawing for demonstration purposes. In the Palo Alto, a default route will also need to be created with the next hop as the management segment gateway. In the isolated Tier 1, a default route will need to be created with the next hop of the inside interface on the Palo Alto. Only traffic that needs to route outside of the isolated Tier 1 router will be filtered by the firewall. Now, multiple isolated Tier 1 gateways can be created to create security zones that will route through the Palo Alto firewall. VMs such as the Palo Alto NVA have a 10 NIC limit, so it would not scale easily if you were to put a NIC in each segment to filter between every segment. Now that we have an understanding of the topology, let's dive into the AVS vCenter console and look at the VM configuration. The OVA installation is straightforward and not covered in this demo. Now we will dive into the NSX configuration of the isolated Tier 1 and segments needed for this demonstration. First, I'll show you how to log into the NSXT console. So we're back at the portal here of our AVS SDDC. Again, if we go to VMware credentials, you can see that we have the NSXT manager credentials here, and we can log in using the URL here. So I'll go ahead and copy that. I've already got it pasted here, but I'll paste it here. You can see it's asking for the username and password, which are provided here in the AVS portal. So I'll grab that password. And the username here is cloud admin. So I'll go ahead and log in. All right, so now we're logged into the NSXT portal. So we'll go ahead and go over to networking. And here you can see this is where we configure our Tier 1 gateways and segments. So for my lab, I created a segment called Ryan-Management segment. And here we can just search here. Here's the segment that I created for the management segment. So we can go ahead and edit this segment. And here you can see how it's been created. This particular segment is connected to the Tier 1, the default Tier 1. So this is how it automatically routes to the Tier 0. You can see here the subnet I put in is 10.128.10.161, and this is a /27. When you create a segment within NSXT, you want to make sure that you put in the gateway, because this segment will actually have the gateway added in here. So 161 is actually going to be the gateway for any workloads that sit on this segment. I'll go ahead and go over to the Tier 1 gateways. You can also see here, I'll show the default gateway, so TNT. This is the default gateway that is created when AVS is stood up. So you can see here, I'll go ahead and edit. This is going to be linked to the Tier 0, the default Tier 0 gateway. And then you can see that route advertisement here is all enabled. So any static routes, any connected segments, everything's going to be advertised up directly to the Tier 0. And then I'll go ahead and show you as well. We'll exit out of this. This is just the default Tier 1 gateway. I'll show you my isolated Tier 1. You can see here, this is my Ryan isolated Tier 1 gateway that I have created for this lab. So I'll go ahead and edit this one. You can see here that it is not connected to a Tier 0 gateway. So that's what makes this isolated. And I'll go ahead and walk through the process of creating this gateway as well. So to create this gateway, you go to Tier 1 gateways. And then you do add a tier 1 gateway. So we'll just name this one test-isolated tier 1. So you do not select a tier 0 gateway. And for the edge cluster, you'll just choose the default edge cluster. And then you can leave all of the rest as default. So you'll save this, and then you can just hit no for continuing to configure, and that will complete the configuration of the tier 1 gateway. So the next thing that we'll look at is the transit segment. So I also created the transit segment and some workload segment. Let's go ahead and take a look at those. I named my transit segment the Ryan-Palo segment. So we'll search for that. So this is the transit segment that we saw on the topology drawing. You can see it's down here, but it's just because I haven't been using it, and I probably need to bring it administratively up, which we'll go ahead and do. So I'm going to do admin state, save. We'll close this. So you can see the segment is now up. We'll go ahead and edit this transit segment. You can see I've given it an RFC 1918 address space of 192.168.21.1/24. And you can tell it's connected to my Ryan isolated tier 1 gateway. We'll go ahead and close that. So when creating this segment, you would do add segment. We'll just call this transit test. Now the gateway we want to connect it to in this is going to be the isolated tier 1. So in here, we'll search for, there's the isolated. And then we want to give it a gateway IP address. So remember, when you're giving addresses to these subnets, you want to put in the gateway. So for example, we'll just do 22.1. Actually, we'll just do 25.1. I don't think that's being used. /24. So that would be an example of a transit network or segment that you could use connected to the isolated tier 1 gateway. And then the default transport zone within AVS is always going to be the TNT or Tenant 48 overlay transport zone. And then we save that. And then you can click no to continue configuring that segment. All right. Once these segments are created, you can connect the corresponding NICs in the Palo Alto firewall to these segments. I'll go ahead and actually log into the Palo Alto. So let's get the IP address of the Palo Alto. I'm going to go ahead and go back to the portal, go to my VMware credentials, and I'm going to log into the vSphere so that we can get that Palo Alto VM pulled up. I'm already logged in, so it will go ahead and go through. Now let's take a look at the Palo Alto. So you can see here, I've got the 3 interfaces. This first network adapter, Ryan Management Desk, it's connected to the Ryan Management segment. So in my diagram, I've saved the management IP here, 10.128.10.162. So we'll take that. And I've already logged into it here, so and then you can see this is the Palo interface. So I'm going to go ahead and log into the Palo Alto. So the first thing we're going to look at is the management IP address. You can see here the management IP address that I'm using. This is located under device and then setup. And then you can see here under interfaces, I've got a management interface. So I'll go ahead and click on that just to verify. So you can see here, I set up the management interface within the Palo. This should be done during the OVA deployment, but just in case you have any issues, this is where you configure it, or if you need to change it. We'll cancel out of that. So the next thing we'll do is go ahead and go over to network. And this is where we'll configure the other interfaces. So you can see here, I've got the outside interface configured and an inside interface configured. So we'll start with the outside interface. This is Ethernet 1-1. You can go in here and see I have created objects for this. So one thing you can do first is actually go into objects and create these, but I'll go ahead and show you here. The outside interface is chosen. So if we go over to objects, You can see I've just got some address objects here. I've created an outside interface object. This is going to be the 10.128.10.163. So if we go back to our topology, you can see that the outside interface of the Palo is 10.128.10.63. And I also created an inside interface object of 192.168.21.5. So if we go back to our drawing, we can see here the inside interface is 192.168.21.5. And this is going to be created or set up on the transit segment, which is actually named Ryan Palo segment. This is the transit segment. I may just make a note here that this is Ryan Palo seg, just for clarity. All right, now that we've got both of our objects created for the inside interface and outside interface, we'll go ahead and go back to network and just verify that these are both set up. So you can see here, Ethernet 1 is outside interface and Ethernet 2 is the inside interface. So the next thing we need to do is we'll have to go back. If you remember from our topology, one thing that we'll have to do is configure static routes in the default tier 1 gateway to represent the isolated segments. So let's go back into NSX. So what we'll have to do is go into the default tier 1 gateway, the one default. So I'll just do T and T here. And then we'll edit this tier 1 gateway. And this is the one connected to the tier 0. What we're going to look for here is some static routes that need to be created. And this is to route back. So you can see I've got a couple of static routes here. This one is the one for the lab. So I've got a route pointing to the 192.168.21.0/24. And my next hop is going to be the 10.128.10.163. And if we remember from our lab, that 163 is actually going to be the outside interface of the Palo. So what we're doing is we're telling any incoming traffic, if it's trying to reach this 192.168 network, it's going to route to this interface on the Palo Alto, the 163.interface. So if we want to add a static route, you just click Add Static Route. You would name the static route. So static route 1. Enter the network that you're trying to route to. For example, 192.168.21 was the route that I was routing to earlier. And then set the next hop. And this would be the 10.128. I'll have to go back to my topology, trying to remember these numbers. 10.128.10.163. 3. And we can leave the admin distance of 1 right now. We're not trying to do any route preferences or anything like that. And you can leave the scope blank. And that's how you add a default route. So we'll go ahead and cancel out of this since we already have our static route in here. Ryan Palo route 1. All right. So in the isolated tier 1 gateway, we will also need to create a default route to the inside interface of the Palo Alto. So let's close out of this and we'll go to our isolated tier 1. And here's the isolated tier 1 gateway. So we'll go ahead and edit the isolated tier 1 gateway. And you can see in here that we've also got static routes. So this is one caveat I have found with NSX, and this is a way of adding quad zeros. It's not necessarily a bug, it just prevents you from putting a quad 0 route in here. But to get around this, you can actually just add 2 routes, one with a quad 0/1, and then one with a 128/1. And this will basically be equivalent to a quad 0 route. And you can see that my next hop for this quad 0 route is going to be that inside interface on the Palo Alto, the 192.168.21.5. And this is for both of those routes. So if you're configuring this and you want to screenshot this, go ahead. But this is how you would create a quad 0 static route from your isolated tier 1 gateway to the Palo Alto, as you can see here. And that concludes the NSX configuration portion. This should get you going with at least having the routes configured, the tier 1 gateways configured, as well as the segments. Next, we'll go into the Palo Alto configuration and show what needs to be done there for the routing. So now let's log into the Palo Alto. We're already logged in over here. So from the Palo Alto, we'll want to go ahead and go in to configure a default route. So this will be done under virtual routers. There's a default virtual router, which we'll use in this lab. And you can see that I've created a static route. So I'll go ahead and click on this. So you can see that the next hop is going to be the default route of the management segment. So the management segment is where our outside interface and our management interface sit. So let's go into the NSX portal and look at that. So if we go to NSX and we go to segments, let's take a look at our management segment. So you can see here, 10.128.10.161 is this IP address space of this segment. So we'll go back to the Palo, and you can see that I've put in 10.128.10.161 as the next hop for this static route. You can leave the rest default. Putting weights and admin distances is out of the scope of this video, but for this will work. So we'll go ahead and hit OK here. So now you should have everything configured. The firewall on this Palo Alto, I don't have any rules, but I'll go ahead and put in a ping rule, and we'll test that in our next demonstration. All right, now that we have configured the NSX segments and tier 1 gateway and configured the Palo Alto firewall, we can do some testing. So I've got a couple of Ubuntu machines. One Ubuntu machine is sitting on the Ryan Palo Alto segment. This is the transit segment. I've also got another Ubuntu machine sitting on the management segment, which is on the other side of the firewall. So this will represent a machine sitting here on the management segment, and then a machine sitting on the transit segment. So the first thing we'll do is go ahead and look at the firewall. I've got some example rules in here that I've just set for allow to now. And then what we'll do is we'll change these rules to block traffic. So I've got a ping rule, just blocking an application of ping from my source address of my Ubuntu machine sitting on the transit segment. And that Ubuntu machine is 192.168.21.55. So that's this Ubuntu 01. So we'll go ahead and do an if config here. You can see that this one's 192.168.21.55. So this is sitting on the transit segment. So for example, we'll go to a web browser here. I'll just start a new tab. And then we'll just go to Microsoft.com. All right. So we can see that we're routing out through from the transit segment out through the Palo Alto. So what we'll do is we can go into the Palo Alto configuration, and I'll go ahead and configure. I've got this rule configured from a source of the 55 machine. So I'll set this to block. We'll go ahead and block. We'll go ahead and block any HTTP or HTTPS traffic. As you can see here, I'm going to go ahead and commit that. We'll commit that. Okay. So now I've got any web traffic basically from my source machine of 55 blocked. So we'll go ahead and go to the Ubuntu machine. I'll close my browser here, start a new session. All right, now we'll just open up a browser and go back to Microsoft.com and see if our firewall rule is working. So Microsoft.com. Okay, we can now see that it's just spinning. So let's check our firewall. We'll go over to the Palo. We'll just look at the monitor logs here, the traffic logs. And we can see here that there's some traffic coming from 192.168.21.55 over port 443, which is HTTPS traffic, and that's being denied. And that's why we're not able to get to the internet. So we'll go back to our rule just to verify. We'll go to our policy. You can see here we're still not able to get to Microsoft.com. It's just spinning. And we'll set this back to allow. And these are just some basic rules. Obviously, you'll have more extensive rules within your company. I'm going to go ahead and commit that. We'll close. Then we'll go back to the Ubuntu machine. Sometimes applying these rules, you'll just have to wait. I've noticed it takes anywhere from 15 to 20 seconds to actually commit. So we'll open up a new browser here. We'll put in Microsoft.com. And then actually we'll just let it spin because eventually it should go through. Sometimes you've got to just check it a few times here. There we go. So now we're getting back through to the internet, going to Microsoft.com. So we'll go to the Palo, we'll go to our monitor, and we can see the traffic is now flowing through. We see an action of allow on port 443 coming from my Ubuntu machine, and it's actually hitting the allow rule. It's actually showing the rule in here. So the next thing we'll do is, since this was from the source out to the internet, we'll go ahead and show a machine that's actually sitting on this management segment. So this will still flow through the firewall. So if we source traffic from my Ubuntu machine, which is on this Palo segment or transit segment, it'll flow through the firewall and hit my other Ubuntu machine, which is sitting on this management segment. So if we look at this Ubuntu machine, we'll go ahead and log in here. And we'll see that the address is on that network. So 10.128.10.168. So I'm actually going to go to my original Ubuntu machine, and let's just try to ping this machine. I think I actually have this in history. There we go. Ping 10.128.10.168. So we can see there we're getting responses. And I'll do the reverse of that as well. We'll go ahead and go to our Ubuntu machine on the other side, and we'll hit the 55 machine. So we can see here ping 192.168.21.55. That is my Ubuntu machine on the transit segment. So we're able to communicate back and forth across the firewall. And in fact, if we go to the firewall, we should see some ping traffic traversing it. And you can see here ping traffic going across the firewall. So let's go ahead and block that traffic. We'll go to policies. We're going to choose our ping rule. This is actually just sourced from 55. So we'll go ahead and block this. We'll do a drop or a deny here. We'll go ahead and commit this rule. Close. And then we'll source it from our 55 machine. So we'll do the same ping test. It'll probably ping for a minute until the rule kicks in. Which I've usually counted about 15 to 20 seconds here. Maybe 25 seconds. And there we go. So now you can see that the traffic is now being blocked. And in fact, if we leave a constant ping going here with blocked traffic, we can go back to our monitor. And we can see the pings being denied by my rule, Ryan ping. And that concludes the configuration of the Palo and blocking and allowing traffic through. This should give you a general idea of how to configure a network virtual appliance within AVS. Obviously, if you have any questions, reach out to the AVS team and we'll be happy to help you. Thank you.